All right, let's try to finish this up. We didn't quite get to it yesterday, so let's do it today. So first example, it's actually example 4 in the book. It says use graphing calculator, but yeah, I am not really going to have you use the graphing calculator. If you want to use it and punch it in there, you can. To be transparent with you, it's been years since I've used graphing calculator, okay? And I'm not going to teach you the graphing calculator. There's other things out that are better now. I mean, the last time I taught Algebra 2 was probably maybe 15 years ago at least, okay? So things have changed, and we have this cool program called Desmos. It's also an app. Download it on your phone, all right? You should have it, all right? Everybody hear me? Okay, you need to have Desmos on your phone. You need to have it available to you. If you want to use a graphing calculator and if you know how to use it to graph this stuff, feel free. It's up to you, all right? But Desmos is so much better and cleaner, faster, just easier to use. You got it on your phone. You got it with you all the time. So I would use Desmos. So what it's asking you to do is, remember we talked about the zeros of a graph? Remember that? So if I had this, what does that represent? Okay, the x-intercepts, and that's your solution when you set that. Everybody listening? Seems like there's a lot of distractions. So when you set your function equal to 0 and you solve for x, what are you finding? You're finding those x-intercepts. You're finding where it crosses the x-axis, correct? All right. Now, there are some things that are a little bit, some problems obviously are easier and harder. The one they're going to give you right now might be a little bit more difficult to find the x-intercepts, all right, with the equation that they give you. So in this example, they tell you to use a graphing calculator, but we're going to use Desmos. I actually have a graphing calculator, a digital one that I could bring up. Have I ever used that in here before? Yeah. Have I? Okay, so boom, there it is. So I could use that, but I'm not going to. All right. Let's see. Get rid of this. Exit. There we go. All right. So we're going to use Desmos instead. Did I spell it right? Desmos. Yep. All right. So here's what we are going to graph. 4x squared plus 5x minus 3. Now they set it equal to 0. You could just say f of x or y equals, right, when you put it in there. If you set it equal to 0, let's see. I don't think I've tried that before. But let me set up my little recording thing so it records the Desmos. There we go. All right, so let's put it in here. So 4x squared. Have you guys used this yet? Yeah. Okay, good. Make sure that you have it on your phone somewhere because there may be, I'm not going to guarantee, but there may be a time on a quiz or a test that I say to graph it using a graphing calculator or graphing program, and you can use it. Now I'm going to be walking around making sure you're not using it for something else, okay? But there will be times, I have no problem with that you use it. Yes, ma'am. Yes, absolutely. Yeah, there's problems on the homework where it says use a graphing calculator. By all means, use Desmos, okay? You can put it on your computer, your tablet, your phone. Works great on the phone. I have it on my phone. Again, it's an app. I just click the button, boom, it pops up, and it's good, all right? I don't know if they give you step-by-step. They do give you some instructions on that. It's example 4, so look for it. Just says use, it doesn't give any explanation. Go to a YouTube video, right, and say, how to graph polynomials with a graphing calculator, a TI 80, whatever they are now. I don't even know what they are. It used to be like 81, then they're 83s, and they're 85s, 6. I don't know what it is now. Who's got a graphing calculator? Hunter, which one do you have? TI what? 83. Okay. So anyway. Yeah, so an 83 is kind of older. I don't know. Is it 80? It's just 84? Okay. All right, good. All right, let's continue with this. Plus 5x plus 5x minus 3. All right, and let's set it equal to 0. Setting it equal to 0, yeah, it does weird things to it. It shouldn't really look like that. Let's not set it equal to 0. Oops. Let's just do that. There we go. And I think I've told you before, it's either this class or the other class. Guys, pay attention. Come on, I'm talking. I don't know if it was you guys or pre-calc class. I'm kind of new to Desmos. I just do real basic stuff, right? I just put the equation in there, look at it. But there's a lot of stuff that you can do. If you go down the rabbit hole of YouTube, all right, and hit in Desmos, how to use Desmos, and man, they will tell you all kinds of crazy stuff you can do with it. It's pretty amazing. I just got to sit down, take the time, and learn how to do some more stuff. But in this case, it's kind of easy. Watch, you just click on it, and it'll show you. It puts a little gray dot right there. You just hover over it, all right, and it tells you what the x-intercept is. It's negative 1 point. It says round to 2 decimal places in the example, so it's negative 1.69. So that's one x-intercept, and there's the other one, 0.44 if you round it to 2 decimal places. And that's all it asks for example 4. That's the only thing they want you to do is just find it. What's another important point, do you think? A couple other important points that you could just look at and see. The vertex, yeah, the vertex would be down here. There it is. It's weird numbers, okay? So this will probably come out to like if you were to actually do the math on this, you'll probably get square roots and all that kind of thing, right? And that's what these crazy numbers are. But that's what the decimal would be. What's another important point? The y-intercept, and they put a dot right there. Well, that's a nice easy one, 0, negative 3, all right, to find the y-intercept. It's easy to find that. You could have done that in your head in like 5 seconds, couldn't you? Set x equal to 0, 0, 0, boom, negative 3. Less than 5 seconds. All right, everybody with me on that? Okay, so that's the only time today we're going to use Desmos, but I just wanted to show you that. So let's go back to this and get rid of that. Click on that. Good to go. All right. So we graphed it. We found the x-intercepts. We found the vertex. We found the y-intercept. Those are good numbers to know. So make sure you know how to use that. All right. It's kind of fun, actually, and it is. It's kind of fun because you can manipulate it. You can change it. You do a lot of cool stuff with it. It is kind of fun. All right. Now we're going to get into the inequalities. That's what we kind of missed yesterday. So these are called quadratic inequalities. Let me just write that down. We've done inequalities in here already, haven't we? Less than, greater than? Yeah, but we're going to do it with graphing. Okay, we're going to graph an inequality is really what we're looking to do here. Yep, dashes, shading, and all that good stuff. All right, so it's y is less than negative x squared. We're going to graph this by hand. We're not going to use Desmos with this. Okay. All right, so in order to graph something that looks weird like this without Desmos, without a graphing calculator, where do you think you're going to begin? We talked about those points on that graph that were really important. What were some of the points that were important? The two things they asked for. What did they ask for in that last problem? The x-intercepts. Okay, so those are two important points. We could find the x-intercepts. Okay, what's another one we can find? What's probably the easiest one we can find? The vertex and the y-intercept is probably the easiest. Vertex shouldn't be that hard, especially if it's in this. Well, not especially, but even if, I'll say that, it's in this form, you should be able to find the vertex, okay? So let's do the easiest one first, and then we'll do the graph, okay? I'm not even going to start graphing it yet until we find some of those special points. Once we find those special points, then it should be pretty easy to graph. Make sense? All right. So let's do the y-intercept. So if we find the y-intercept, what do we do to find the y-intercept? We set x equal to 0, right? That's pretty easy. So that goes to 0, that goes to 0. So what's the y-intercept? Negative 3. But it's a point, so it's 0, what? Negative 3. Because what'd you do? You set the x equal to 0, right? That's why the 0 goes first. You solve for y, and it's negative 3. Everybody with me on that? Yeah, super easy. Now, that alone is not really going to help you to get the graph, all right? You got to know some other stuff. So let's do the vertex next, all right? So that's the first thing we're going to do. The second thing, I'll put a 2 here. The second thing, let's find the vertex. So we have, especially, now what if it was in that form where the x minus h quantity squared plus k? What if it was in that? You could pretty much just look at it, couldn't you? And tell what the vertex is. So you could put it into that form if you wanted to. But if you didn't and you just wanted to keep it in this form, you have a little way to do it. Do you remember how to do this? What's the x part of it? Negative b over 2a. Good. So that's the x part of the vertex. And then it's what? Negative b squared over just 4a, so you're not squaring the a, plus c. All right? What's your a? A is negative 1, yep, and b is 4, and c is negative 3. All right? You just plug it in there, and you got your vertex. So let's do that. Negative b, so that'd be negative 4.
Please escort them to the cafeteria to clean it up now.
No, stay here. This is more important. All right, so it's negative b, all right, over 2 times a. So 2 times negative 1, which is negative 2. We'll simplify that in a second. All right, let's do this. B squared, so that'd be 16. That'd be a negative 16, right, over 4 times a. So that would be what, a negative 4 plus c. What's my c? It's a negative 3. All right, let's figure this out. We should be ready now. That's going to be 2. This is going to be 4 minus 3, which is 1. And there you go. That's your vertex. That's a super important point to graph, isn't it? All right, so let's keep that right there. And what's the third thing that we can do? Yeah, find the zeros. Find the zeros. All right, and how do we do that? Well, we're going to take our equation. Well, it was an inequality, but we're going to make it an equation. We're going to set it equal to 0, all right, just so we can see where it's located. Remember, our whole graph is an inequality. That's true, all right, but to find the zeros, we're going to set it equal to 0. So I've got negative x squared plus 4x minus 3 equals 0. Now, what we have to do is just solve for x. Once I solve for x, that's the zeros. That's where my graph is. Well, it would actually be like this, wouldn't it? It'd be, right, because it's a negative x squared, so it would be opening down, all right? And so, but that's where it would hit the x-axis. What's the first thing I would do here? I don't like that negative in front of this. Let's just divide everything by a negative 1, all right? Because I can divide that by a negative 1, and I just still get a 0. So what am I going to get right there? X squared, what's that going to be? Minus 4x, what's that going to be? Plus 3, good. See what I just did? I divided everything by a negative 1, or you could look at it as I multiplied it by a negative 1. Doesn't matter, you still get the same thing. Now, they kind of rigged this a little bit for us to make it nice and easy, all right? So it comes out to nice integer type numbers. It's not always going to be like that, but on this example, they do that for us. So what do we got? X and x. Do we have something? Do we have something that multiplies to be positive 3 and adds up to be negative 4? Well, not just 1 and 3, but because they have to add up to be a negative. It's not 1 and 3. What is it? It's negative 1 and negative 3, okay? Because when you multiply them together, it's positive 3. When you add them up, it's a negative 4. Now, what do we do with this? I'll show all the steps here, just in case you get lost when you're looking at your notes. So we set them both equal to 0, and then we add a 1 to both sides. So x is 1 and x is 3. So there you go. I'm going to put the important points in a box. Is that all right? It is all right. So these right there are what we're going to use to graph. Let me grab a graph. All right. Hopefully I left myself enough room. Yeah, I can make it a little bit bigger than that. Oops. Where am I? There it goes. All right, that should be good enough. Let's go to a different color. All right, let's put these points in and kind of see what our graph looks like. We have an idea already what it's going to do, don't we? We know it's going to open down, so we know that. Okay, let's do the vertex first. 2, 1. So there's 2, 1 right there. 0, negative 3. 1, 2, 3, right there. And then 1, 3. X is 1, so the x-intercept right there, and then 1, 2, 3 right there. There's another point that we didn't really find here, but we could figure it out. See that y-intercept? Where is it? I mean, you could figure out where it is in relationship to this point or the vertex. Let's do the vertex instead. So how did you get from the vertex to the y-intercept? Well, you went to the left 2 and what? 1, 2, 3, 4, down 4. So what are we going to do to find the mirror image of this point? We're going to go to the right 2 and down 4. Everybody see that? So that's a point we didn't find here, but we could very easily graph it. I mean, it's almost done for you right there, isn't it? All right, so, but we got to be careful because remember what this is. This is an inequality. So it's not an equal sign. It's what? It's a less than sign. So are we going to put a solid line or a dotted line? A dotted line, okay? So that's important. All right, so I'm going to make this dotted. Goes like this. Make this dotted. And it goes something like that. Is that all? Just the dotted line? We got to shade it, don't we? Serious. Okay. So we got to shade it. Where are we going to shade it? We're going to shade it like inside of here or outside of there. If you're not really sure, let's pick a point. Let's put it in and see if it really works. Okay, remember, here, I'll tell you what, I'm going to rewrite the inequality and I'm going to make it an inequality. Let's pick a point where you know for a fact that it's either outside or inside. So this is going to be y is less than, correct? All right, so let's do that. 2, 0? Yeah, 2, 0 would work, wouldn't it? Looks like 0, 0 would work, but I don't know. Maybe that's a little bit too close to that. Maybe I didn't do the dotted, but 0, 0 looks like it could work, right? Let's try 0, 0. And then let's try 2, 0, all right? So 0, 0. If I put a 0 in for that, whoops. If I put a 0, that's 0, 0, negative 3. Is 0 less than negative 3? No. So 0, 0 is outside of the parabola. So do we shade outside the parabola? No, this tells us that we do not shade outside the parabola. Let's do one inside the parabola just to make sure. And Zach said 2, 0 is definitely inside. Would you agree? Yeah, because it's below this one and it's in between these two. So 2, 0 would work. So let's put a 2, 0 in for that. So the y is 0, so you put a 0 here, less than. Let's put a 2 in for this. This is 2 squared, which is 4. That would be a negative 4. Put a 2 in for that, that's plus 8. And then put minus 3. That's 4 minus 3 is 1. Is 0 less than 1? Yes, it is. So what does that tell us? It tells us we shade where? Inside of that parabola. Okay? Everybody with me on that? So when it says less than, what do you think? Where do you think you shade? Instead of going through this all the time? If it says less than, you probably shade inside the parabola. If it says greater than, you would shade what? Outside the parabola. All right? So that's kind of helpful. But this is kind of like our comfort zone, you know? It's like it just makes me feel more assured that I'm shading in the right place, okay? And it only takes just a second, doesn't it? And usually 0, 0 is a point that you could pick, so you could very easily put it in there just to kind of guarantee that you're shading in the right direction. Does that make sense? Okay. And that's it. So really, could you have ever imagined just a week or two ago that you'd be able to graph, well, with the inequality, that you would graph an inequality like this? Probably not. All right, but now it's not even that hard. Isn't this way better than doing this thing and then picking a whole bunch of points and seeing where they go? Yeah, absolutely. All right, and that's what we're trying to do. Okay, we're trying to find out what all this stuff means and the significance of it. Put some key points in there, and you're like, oh, okay, that's what it looks like, and then you just make your graph. We good? If you're at home, I would not suggest using Desmos first and then graphing it right from the phone. All right, that's not going to help you because you may have to do this by hand and not use the calculator or phone at all. Okay, but when would be a good time to use Desmos for something like this? Say it again. To check your answer, right? Okay, do the graph, see what it looks like, and then put it in. I'm curious if it does the shading and the dotted line thing. I haven't tried that before, so let's try it. I'm sure it does. I just haven't done it before. It is. All right, so what was it again? Y is what? Less than? Is less than negative x squared. Ooh, look, it already does it already. Negative x squared. What was the rest of it? Plus 4x minus 3. So plus 4x minus 3. And there it is. Cool beans. Isn't that awesome? All right, if you click on it, let's see, maybe you got to click right there. Yeah, click right there, and it tells you the vertex. There's your 2, 1. There's your x-intercept, 3, 0, and 1, 0. And it even tells you your y. And if you come over here, you could, if you click on it, there it is. There's your 4, negative 3 that we put in there, right? We figured that was there. And if you wanted to, you could put other points in there as well, couldn't you? All right, you could put a 5 in there to see how far down you go. But if you go over too far, then you're going down way further than you ever want to draw, right? So this is good enough. And they even put the dotted line in there and everything. Kind of cool, huh? Yeah? You're not as impressed as I am? All right. Okay, let's go back to Illustrator. There we are. All right, so how many of those inequalities did you have to do? You know, I did like 3 or 4 of them, right? 2 of them, only 2? Okay. So let's do this. Let's use the rest of the time to finish up those 2, and then you won't have any homework, okay? So it was 17 to 33 odds. Say that again. Oh, it says do it on the calculator? Okay. If it says use a calculator, then... So you got 3 to do? The inequalities? 4 of them? Okay, that's what I thought it was. All right, get those done now, and then you can turn them in when class is over. You got about 20 minutes, 23 minutes. All right, so get that done, and that's all you got. So I'm not going to do a new lesson today. Say what? Yeah, Monday. Yep, no school tomorrow. And I got all my notes for the rest of the chapter, so I'm ready to go.